You might want to turn, there you go.
Thank you. The Proctor U is out there, so. Make sure you make those testing appointments. Okay, quick review here on Project 1. Most of you did great. It is high points and high weighting. The ones that came in early were by far the best ones, so the lesson is not to procrastinate. I did give you feedback and I sent an email. Some of you that made some grave errors, this time only I was giving you a opportunity to resubmit. I wanted them resubmitted by the due date, but I'm now giving you until Sunday. So to be fair, anyone that didn't submit one, you may also submit one till Sunday. You will not get full credit. Resubmission, I am taking 10 points automatically off, but don't expect this the next time. It appears some people did not print out all the instructions. There was a student guide that took you through step by step on how to format the cells had to be formatted. They couldn't just be typed in. You couldn't calculate the things by hand. And then there's specific things, if you look on the rubric, that are 5 points each. If you didn't answer those questions, it's automatic 5 points off on each one of them. And there's even check boxes on the assignment where you can check off that you've done that and then use the rubric to self-grade. Project 2 is assigned and out there. I suggest you start soon, not later. I did remove, thanks for somebody that let me know, the ones that said they were Project 2 were actually Project 3, and the one Project 2 that was in there as a sample I looked at and it wasn't very good. So I sent you another sample, and it is not to be followed. It's not a perfect paper. It's missing some things, and it's different questions than you get, so you can't just follow the paper. They get different questions each semester. It's just an example of how a paper should flow using paragraph forms, intro paragraph, things like that. I did notice on that paper she didn't go into what she put into Excel, which a lot of you left off. You need to put in your formulas in your paper. This is the formula that finds average. This is the formula to use to find the mean, the median, the mode, and to report all your data. So I think after the first one, some of you be much more comfortable. There's still workshops you can sign up for, still the Learning Center, but there's no reason not to get those points. Some of the papers you had were very good. I changed this week's discussion board to try and get you to start outlining your paper now and writing an intro paragraph, and the ones I've had are very good. And I've asked somebody in class to let me share theirs. I may be posting it later if I get the okay from them, because they did such a good job on it. Any questions on projects? Okay. I just said I revised the discussion board. There was one person that had done it. You don't need to change yours. I went ahead and graded it the way it was. So today we have section 12 and 13. I sent you an email on 13. The two multiple choice problems were very confusing. It didn't go along with the definitions in the text. So if you didn't do those, I will give credit back that much percent, up to 100%, on problems 2 and 3 in section 13. I even asked a statistician, and they got it wrong the first time. It was just minute little things in the words that were very hard to find, and they don't have any test questions or haven't that lined up with those two questions. So I see some of you are still struggling. I think section 11 and 10 and 11 are probably the two, for most people that take this course, they find those two the most challenging sections of the entire book. Get help. Don't wait. Go to the supplemental, Learning Center, office hours, student study groups, and follow the factor label method. If you don't do that, it will not work if you just try to multiply and divide things. But once you learn the factor label and keep following, it gets much easier. What we add today in section 12 is just one more conversion. So it's still the factor label, so it should give you some more practice at it. The problems are long. If you do one part at a time, it's really, no part of it is bad. They're just long. which that gives a lot of people problems. So all we're adding this week is the conversion that's on your yellow sheet. 1 gallon of gas equals 19.8 pounds of CO2 released into the atmosphere. You need to know nothing about chemistry. When you hit the section in the book, you don't have to know any of that. And 1 kilowatt hour of electricity produces 1.37 pounds of CO2. It gets emitted into the atmosphere. Additional thing from our metric system, this is a kilo prefix. Most of the time you are given what an appliance uses in watts. So the first thing you have to do is make that into kilowatts by moving the decimal 3 to the left, or you can use the conversion 1000 watts equals 1 kilowatt. That direct conversion is not on your sheet, but you do have the metric prefaces the base unit to the kilo. So you can use that. So the two things we're working with now are down towards the bottom of your sheet, third section from the bottom. The CO2 from gas, 19.8 pounds per gallon. CO2 from electricity is 1.37 pounds per kilowatt hour. You've got two units here, kilowatts and hours, to cancel. Now, maybe a little easier to see with an equal sign. Okay, just like I had written. 1 kilowatt hour, 2 units, kilowatts and hours equals 1.37 pounds of CO2. Okay? So when you're getting your conversion, you know that you aim to get gallons to use this conversion, and here you want to get kilowatt and hours so that you can use this conversion. Okay. One other thing on the agenda I had here, actually this is Robin, the one you were talking about. I put it on the agenda even. Be sure to have non-usage hours when calculating vampire hours. You have two charts in your book where you get the watts. Sometimes they put it in the problem, but you need 102 is the regular watts. 103 is what they call vampire, when an appliance is plugged in but not being used. Okay, so you have to have the hours of not used. Then we have the quiz. We'll go over some problems from it. And don't forget you have an Excel assignment that's not Project 7 this week. It will help you get ready for Project 7. It's making a bar graph and a histogram from data, deciding which one should be a bar graph and which one should be a histogram, and we'll look at that today too. Okay, questions? All right, so just the basic conversions with gas, gallons of gas. If we know the gallons of gas, like number 1 tells us, 19.1 gallons of gas is the, and if you use all 19.1, you have what you need. It's not per anything. You put it over 1. Keep using the factor label. We know our conversion now. Do it the same way. Since gallons is in the numerator, we need it in the denominators, and then go to pounds of CO2. That will be our cancel our gallons. Common factors cancel numerator to denominator. This is on our sheet. 1 gallon equals 19.8 pounds of CO2. Okay. So all this is, anything in the numerator we multiply, any non-1 digits we divide by. So all this is multiplication. 19.1 times 19.8. Round to the nearest tenth. And don't forget to label. Well, your computer does that a lot for you. If you were paper and pencil, you would label 378.2 pounds of CO2. So this is just one more conversion. You're still using factor label and unit fractions. Okay. The other type on the gas Remember, it could be for 1 day, for 1 week. You got to keep going. If it gives you more than, they give you a day and they want a week or a year or a month. But they can also give you, your car gets 29 miles per gallon. So they're giving you a conversion, a unit fraction here. 29 miles equals 1 gallon. How much carbon dioxide is emitted when you travel 85 miles? Remember, we don't need miles. We need gallons. So this is just real life. If you drove 85 miles, your car gets 29 miles to the gallon. How many gallons did you use? Well, this can be set up either way, and it only makes sense we would divide 85 miles we drove by 29 miles per the 1 gallon we get, and that's going to give us the number of gallons. Now you can do it in one step or in multiple steps. If we do this in multiple, that would give us 2.93, you can't round, you got to use a bunch of digits, gallons. Once we have gallons, you're ready to convert. That's what we need. 1 gallon is 19.8 pounds of CO2. So it's just times 19.8. And we get 58 when we round to the nearest tenth. Okay? Okay, questions? Finding those okay? Anybody need any more of those? Or should we go on to the electricity ones? Somebody have an opinion. Shauna is okay. Thank you, Shauna. How about Brooke? Is that better, Brooke? Okay. Okay, so our conversion for electricity is what? 1 kilowatt hour equals 1.37 pounds of CO2. Okay? So let's start out with the basic one, and then we'll go to Robin's nemesis number 5. Let's just start out with an appliance. I'm going to make up a problem here. You'll need to have your page 102, 103 ready. Okay, try that one. The homework doesn't have many basic ones. It goes to some more complex ones, so yeah, you need to be going through the textbook, watching the videos, filling it in first, and then doing the homework. Okay, who's going to start us off? What do we need here? Has anybody read their sections? I know Robin has. If we're doing conversions with electricity, you need to find, there's Brian, find the watts. That's right. So you go to page 102 and you look for PlayStation 2. How many watts is it? Good. Laura, Crystal, it's right here. 50 watts. So that's where we're starting our factor label, 50 watts over 1. All of the conversions have to be in kilowatts. So that's your first step, 1,000 watts, because we need to get rid of watts and go to kilowatts. Okay, so you'll always be converting to kilowatts. Now our conversion, we need hours. How many hours is it used? It's 10 hours, and that gave us per week. But they want our answer in pounds of CO2 per week, so the week is good. Now I have what I need to use my conversion, because you need kilowatts and hours. So now we use our conversion. What goes in the denominator? CO2 or kilowatt hours? We need the kilowatt hours because we need to cancel the kilowatts and the hours and go to pounds of CO2. So 1 kilowatt hour is 1.37 pounds of CO2. Okay. Now it's just everything that's non-1 you multiply in the numerator, divide by anything non-1 in the denominator, and what do you get? And I didn't tell you where to round, so Laura's got it. Okay. Look at number 2 and see what you can come up with on that. Where do we need to start? Crystal is correct with the watts. How do you know the watts if it's not in the question, if they don't tell you? You go to page 102 or 103. Okay, Robin says 120 watts. And she is correct. She got it right here off the page. But do we ever use watts? Our conversion is not watts, it is what? in kilowatts. So we need to convert watts to kilowatts. 1,000 base units, 1,000 watts equals 1 kilowatt, which gives us our kilowatts. We also need hours in our conversion. How many hours is this used? Underline the things in your sentence, and that needs to be in the denominator or in the numerator here. And it's 6 hours per day, so it's 6 hours per 1 day. Now we can go in different orders. We can do the CO2 conversion and then the year, or you can account for the year and then do the CO2. It doesn't matter which order you go in. So since we've got the kilowatt and the hours, what we need for our conversion, I'm going to go ahead and do my conversion to pounds of CO2. 1 kilowatt hour, that cancels the kilowatts and the hours, is 1.37 pounds of CO2. This is what I need in the numerator, but they don't want to know a day. You still have to account for a year. Okay, Megan, we're holding up.
Okay, so my question is, in the problem above then, at what point did you multiply that? Never mind, I got it.
They gave us hours in a week. Is that what you're, okay? And again, this can be in different order. Like multiply by 365 days a year. You could have multiplied by 365 days first. It doesn't matter. Okay? So 365 days, that'll cancel that and go to 1 year. Now we have what we need, pounds of CO2 per year. So it's just multiply the numerators, divide by the denominators. And there's a shortcut here. You can always just start out, move your decimal 3 to the left. And did you get 360.036? Did anybody get that? Did I put it in my calculator right? Yep. Some of you stopped right here and then multiplied by 365. If you stopped right here, you got 0.9864, but then you had to multiply by 365 days in a year. And this would be your final answer because it said in a year. Okay. All right. Now let's try a standby one. Okay. The next section goes into energy vampires. It was on page 103. They call it energy vampires, non-usage hours. And there are people that run around, and I had some in my last class. I don't know if any of you are like this, and you unplug everything when not in use. Your stove, your TV, your anything that you're not using, you unplug, because most appliances still draw energy even when they're not in use if they're plugged in. And as you can see, it's a much lower use. Like a TV, they estimate 3.06 watts when it's not in use but plugged in. And when it's in use, they've got two different types, 250 or 345, a big difference. So some people claim to be doing this to be green and save our environment, and some people are very, very cheap. They think they're saving a lot of money. I don't have the time to run around and plug everything in, so I don't do it in and out. And there's some different philosophies. Some people think it takes more, like if it has a fan or something, it takes more energy to ramp up than to leave on. So again, this is all, you don't need to understand the science, you don't need to believe it, we just need to do the factor label method. And again, this is all very estimates because TVs are different, okay? Different ones would pull different amount. So on 103, they just give you a sample of a few appliances and what they estimate they pull when they're plugged in but not on. Now the trick to this section is you have to figure it out when they tell you non-use vampire hours. You have to have the hours they're off. Sometimes they'll give you the hours they're on, so you'd have to subtract that from the hours, total hours in the day if it's a day, and a week if it's a week. Okay, so I'm going to start out with the one that's basic. It's going to be a TV, so we can get our watts in standby mode. So our watts are 3.06 because this is for standby vampire energy. How much is emitted from your TV if you're not using it for 16 hours a day? So this one's easy because it's telling us we're not using it that much. So we need to first always do our watt to kilowatts. 1,000 watts is 1 kilowatt. And then the other thing we need is hours. 16 hours non-use, which is what we want, per day. And we're just doing it for the day. It doesn't say for the year, for the week, for the month. So now we're ready with our kilowatt and our hours. 1 kilowatt hour is 1.37 pounds of CO2. And we get 0.067 pounds of CO2 per day. Okay. Okay, now comes the trickier ones. How much CO2 is emitted from standby power from your TV in 1 week if you watch TV for 35 hours a week? What's the trick on here? Did they give us the non-use or the usage hours? Speak up, people. They gave us the usage and asked for the non-usage. Okay. So in order to find how many we didn't use, we need the total number of hours in a week. So there's 24 hours in a day times 7 days in a week. So there's 168 hours in a week. Okay. We're using the TV 35, so we need to subtract the usage. This is our total to find the non-use hours. So it's 133 hours. Okay. So we'll start out with our 3.06 watts over 1. Got to convert watts to kilowatts. Now we do our hours. We're not using 35. We're using 133 hours in 1 week. Okay. This gives us our conversion we need here, 1 kilowatt hour is 1.37 pounds of CO2. That cancels both of these and gives us what we want. Okay. And that will take us to number 5, Robin, for you, which is similar to this problem. Any questions before we get to number 5? Okay. I bet you can do it now. If you use your television for 5 hours a week and do not unplug it when it is not in use, how much CO2 is produced from the vampire energy? So we want the non-use hours. Okay. And they want to know for 1 year. Underlining helps. Okay. They gave us the 5 hours a week. So the total hours in a week, we just did that, is 168. Minus the 5 used gives us 163 non-usage hours, our standby hours. Okay. Because they gave us the usage, we had to subtract from the total hours for that period, a week, and come up with the non-use hours. So we start out with our standby wattage for is it a TV again? TV, which is the one we've been doing, the 3.06. Watts to kilowatts. Now we need our hours. Hours in 1 week. Now it's where you can, right here, you can go in different order. Because we need to go a year, you can take weeks to year, or we can do our conversion right here to pounds of CO2. Okay. 1 kilowatt hour, that gets rid of those. Converts to 1.37 pounds of CO2. So we now have the pounds of CO2 for a week. Rob, you've did the 163. That's normally the problem. Now we need to do the year, 52 weeks in 1 year. So you got to multiply what you had by 52. And we're going to the nearest tenth. About 35.5 pounds of CO2 per year. Yeah, we need the per year there. Okay. If you embrace the factor label and you follow the canceling numerator to denominator, you can do this. You just got to do it one cancellation at a time. Okay. Any questions on 6 or 7? 7, I'll just give you a warning, it's not a good question. They say the garage door opener, and they don't tell you how many hours of non-use. Make yourself a note, they're considering it non-use for 24 hours a day, and then you'll get the right answer. So the non-usage hours on numbers for the garage door is 24 hours of non-use a day.
Would that be the same thing for the security system?
Is that what you drew on your question?
Yes.
I've never
Yes.
drawn that, but if it didn't give you any hours, I would say yes. Then use 24 hours, and I think that's a terrible question because they don't tell you that, how many hours. Okay. So let's take a look at your quiz for that section. Problems off of the quiz, and see how you can do. How many pounds of carbon would you prevent from entering the atmosphere in 1 year if you were to replace, we didn't do one like this, it is in the homework, a 100 watt light bulb with a CFL of 25 watts for 1 year, and you have it on for 9 hours per day. Okay, so the trick here is starting out. It's saying how many watts are you saving? So how would we find the savings in watts between these two different bulbs? Well, think money. If you bought one shirt for $20 and it went on sale for $15, how much money could you save if you bought the one on sale? And Scott, you can do both calculations and then compare, but this is going to be a much shorter way. All you have to do is the 100 watts minus the 25 watts. You're saving 75 watts. And there's nothing wrong if you want to do both of them and then compare, but this is going to be a much quicker way. Okay? So we start out with, we are saving 75 watts. We just found the difference. Okay? Over 1. Our next step is 1,000 watts to 1 kilowatt. Now, how many hours are we using it so that we're saving? I wrote in a 9. So 9 hours, but it's per 1 day. Okay. Again, I have what I need here. You could go ahead and do the year first, but I'm going to do my kilowatt hour to pounds of CO2. That takes care of those. I've got what I need here, but I need to change day. Since it's in the denominator, I need to put it in the numerator and go to year. How many days are in a year? Days in a year, weeks in a year are things you're going to have to know. 365 days. That'll cancel the days, and that gives me what I need, pounds of CO2 per year. Multiply, 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 divide by any non-1 denominator. Scott is fast with the calculator. Anybody got a second on that? Yep. Round to the nearest tenth. So we got 337.5 pounds of CO2. Okay. Again, not hard, just long. You just got to underline, take everything out, and follow the factor label to get to the unit you need. Okay. Number 2, a gas tank of a 2013 Honda holds 18.2 gallons. How many pounds of carbon are produced by burning an entire tank of gas? So we have what we need to begin with. 18.2 gallons over 1. What's our conversion? For gasoline, 1 gallon is 19.8 pounds of CO2. Gallons cancel. We have what we need, so it's just multiplication. 18.2 times 19.8. Round to the nearest tenth. 360.4 pounds of CO2. Next one on the quiz. Let's hear some voices. If a truck averages 12 miles to the gallon, how many pounds of carbon dioxide are emitted into the atmosphere when the truck travels 211 miles? What do we need for our conversion? We need plain old gallons. How are we going to get there? Somebody speak.
Divide the 211 by 12.
Thank you. We have 211 miles we're given that we traveled, and we're given this conversion right here about our truck. 12 miles equals 1 gallon. Okay, we're given that. It's not on our yellow sheet, but it's given in the question. So we know we need to cancel miles and go to gallons. Now we're ready for our conversion. 1 gallon is 19.8 pounds of CO2. Work that out, and I've got to see who I'm missing. Sarah, are you here? Sarah or Fallon? Okay, no Sarah or Fallon. Okay. Okay, who's got an answer for me? Gallons cancel. Jacob says it already went by. Oh, I got 2 different answers. I'm getting 3 different answers. .15 pounds of CO2. Okay. It is the same process, factor label with unit fractions. We just added a new conversion. 1 gallon equals 19.8 pounds of CO2. 1 kilowatt hour equals 1.37 pounds of CO2. Okay. On section 13, talks about, you're moving away from this, which makes a lot of you happy, histograms and bar graphs and frequency tables. Okay. This is your project, or your assignment for the week, not your project, your Excel assignment for the week. Use Excel to create a bar graph or a histogram for each table. Use the appropriate graph for each table. Who can tell me which one should be the bar graph? I'll call this A and this B. Which should be the bar graph and which should be the histogram? Megan says B is the bar graph and A is the histogram. She is correct. Laura agrees with her. The difference between the two, a histogram, the bars touch. There's no gaps. Okay? Here, you just have bars. These are of no width in particular. These are the width of an interval, whatever the frequency is. On a histogram, you have intervals. This is 0 to 2, and they need to be the same. The next one would be 3 to 5, 6 to 8, except a lot of times they'll just go 0 to 3 to 6 to 8, and there's 2 in every one. Okay, so this has a width associated with it. Even though it shows a width, this one does not. Okay, histogram is only numerical data. Normally, it's continuous intervals. Okay, a bar graph can be any category. It can be a color, it can be a type of car, it can be a preferred exercise. This cannot be a histogram. Histograms only have the numbers. And I like Megan says continuous. She is correct. Okay, so when you do your project, this is what you want to be your weekly assignment in Excel, week 7 assignment. This is what you want to be the histogram. And you make a bar graph and you click on the bars and then put format data, and then you get rid of the gaps. That's how you make it into the histogram. Okay, and then don't forget, it also asks you, is it symmetrical left or right? How is it skewed? So you have a question to answer. It doesn't take very long. You have a help button for Excel. You have directions in the book that take you step by step on how to make a histogram and how to make a bar graph. So it is not a lengthy assignment if you use your resources. You can get it done very quickly. I know some of you already have it done. I think Laura has hers done, and Scott maybe. A couple other people have theirs done already. Okay. On to some questions on 13. Here's one of your quiz questions. This is a frequency table. Here's the number of children. This is how many times it occurs. It's like our weighted averages. This 0 isn't once. There were 8 response of 0. So if you would list it out, it's like that's 8 times. The 1 is 11 times. That would take forever. It's much easier to make a frequency table and account for, there's 8 of these, 11 of these, 18 of these, 11 of these, 6 of these, 4 of these, 3 of these. You did that in weighted averages called counts. Okay. Now it's saying what proportion of the families in the survey had at most 3. Don't go too quick when it says at most, at least, not more than. Think about what that means. At most 3 children would be how many children? What would be included? Scott says 0 to 3. I agree. At most 3 includes 3. It can't be more than 3, so 0, 1, 2, or 3. When we write a proportion, it's the part over the whole. The whole was given 64. If it wasn't, you would add these all up. So then we need the 0, 1, 2, and 3. We need to add those up. And we get what? 48 over 64. Which reduces to 3/4 or 0.75. Okay. Question on that one? Okay, here's a frequency table. How many families had at least 5 children? At least 5 means 5 or more. Okay, so you have to look. There's 4, 2, 1, 2, or 1. Okay, so what do those add up to? 10. Okay. Okay, that is all of your quiz questions. And we have a request here for number 6 back in section 12. A PS4 uses 8.8 watts on standby. Okay, so we don't have to look it up. They gave it to us. How much electricity would be used if you have your PS4 on standby 22 hours a day for 5 weeks? Okay. So they're asking this in an A and a B. The first time I did it, I gave them the final answer, pounds of CO2 in A, and that may be what you're doing. They just want to know how much electricity first, and then they're asking a second question, how many pounds of CO2? And we go to the nearest hundredth. So A is just how much electricity. Okay. So we have the watts, and they want it in kilowatt hours. So we have to do the 1,000 watts equal 1 kilowatt. How many hours a day? It's on standby. "22 hours, 1 day." But that's not all. It wants it in 5 weeks. 7 days in a week. And then we need to take that times 5 weeks. Okay? Because they want it for 5 weeks. This would cancel here. Days would cancel. And then we'll just get 5 weeks here. So And it said nearest hundredth, so 6.78 pounds of CO2. Okay, does that help, Afolabi? Then you go to B. They just did it in 2 steps. Now we convert, I'd put pounds of CO2, sorry, kilowatt hours is where we're at per week, 5 weeks. Okay. So this is the kilowatt hours for 5 weeks. 1 kilowatt hour is 1.37 pounds of CO2. That's going to cancel my kilowatt and hours and leave me with pounds of CO2 for 5 weeks. Okay. And this we're rounding to the nearest tenth. .3 pounds of CO2. Okay, that answer your question? All right, good. Anybody else? Because our time is up. If you're struggling, just get help. Go to supplemental sessions. Go to the Learning Center. Meet with each other. I have extra office hours. Sometimes you can make appointments on Thursday and Friday. I have a meeting next Thursday morning, and this Friday I'm on a meeting from 8 until 3. So I won't be available for those extra times, but you still have my other office hours. Schedule your test. Start your project 2. If you're resubmitting project 1, look at your notes in there. Make sure you do that by Sunday. Okay. Thank you. I'll be here a second for anybody that's got questions that maybe doesn't want to say them in front of everyone.